Hello students, welcome in chapter 11, 3-dimensional geometry. Students, today I continue our examples, miscellaneous example 229. To prove given lines are coplanar, it means I will prove both lies in the same plane. Line L given and line M given. Students, before starting this sum, I tick this is IMP numerical. So exam oriented you will tick mark in most IMP sum. Two lines are given. So first of all I obtain that passing through n directions. Here passing through A and direction L. Passing through formula known x minus x1. So what's the x1 place? Minus common, then A minus D. Yes, A minus D. If you minus common taking, then same here, already available A. And Z minus Z1 minus common, it will cover to A plus D. That's your third position value. Legal formula x minus x1, that's why I written that. Y minus y1 and Z minus z1, so A plus D. And directions alpha minus del, alpha and alpha plus del. Similarly students, here I will write down to M, x minus x1, y minus y1 and z minus z1, beta plus gamma. Very easy. Your x minus x1 is here, b minus c, same as here b as it is. And last students, if you minus common, then b plus c. So your passing through value b and direction M is as it is obtained. So what you get? B minus C, next B and B plus C. Now I will prove both lines are coplanar. So if we prove N and M are coplanar lines, that means definitely your this determinant is equal to 0. We prove x2 minus x1, y2 minus y1, z2 minus z1, here L1, L2, L3 and M1, M2, M3. We will prove if you coplanar, then follow these conditions. This taking your x1, y1, z1 and here taking x2, y2, z2. Direction are remaining students. I will mention here beta minus gamma, beta and here beta plus gamma. These are the three our directions. So now I start slowly my condition x2 minus x1, y2 minus y1, z2 minus z1, L1, L2, L3 and M1, M2 and M3. So respectively apply that value. x2 minus x1 means this x2 minus this x1. So students, B minus C minus A plus D, same as B minus C. Second value x2, this x1. Now third, x3 minus x1. So B plus C minus A minus D. In other L direction, M direction are same as, what's your L direction? Alpha minus del, alpha and alpha plus del, and same as beta minus del, beta minus gamma, next beta and beta plus gamma. Actually students, here important question is that's why, because here one of the vector using and one of the our property of determinant using. I here using determinant, this third row, third column, add into first column. We easily prove our answer. So is equal to, here just I added third column, add in first column. You will get B minus C minus A plus D. Here added B plus C minus A minus D. Same alpha minus del plus alpha plus del. And last beta minus gamma plus beta plus gamma. Actually this process wise I will prove easily 0 because first and second column are same make B minus C alpha beta And last here same as it is you mention the answer beta plus gamma. Now you check here what remaining. Here remaining is a just only you're going to your C cancel and D cancel, B 2 times, A 2 times. Here students your del gone, your gamma gone. So remaining steps ahead to that. After that 2 times here B minus C, 2 times alpha and 2 times beta in that parts. Other same is B minus C, alpha and beta, and last as it is alpha plus del and beta plus gamma. Now here I will just mention the condition apply. What applying? C1 column change, C1 plus C3 first column and third column addition. Now here common take 2 successfully, B minus C, alpha beta, B minus C, alpha beta, and the same as. Now students, you will check your column number first and second are same, so value 0. So 2 into 0 because C1 is equal to C2. That's why this answer is 0 proofing. So is equal to 0. So I will say L and M both are coplanar lines, and that the students easily we will cover the answers in the parts of example 29. Now I continue same as example students 30 and 30 also IMP for board exam related questions. The 30 is IMP questions. Example number 30. So before starting this sum, I will tick mark in the IMP list and there is a IMP question. Now continue students. Example 30. Find the coordinates of the point where the line passing through the A and B given cross the XY plane. It means students, this is your plane. Just I consider XY plane. Definitely they have one of the position points on that plane. XY, it means Z is absent. So here X comma Y comma 0. And here one of the line passing through on it in the XY plane. And I want to that point X comma Y comma 0. Very easy. First I define A and B related directions and equation of line AB. So for given A 3 4 1 and second 5 1 6, I decided direction of AB. Very easy. B positions vector minus A position vector, that create simple way your directions. So B I have students 5 1 6 and A 3 4 1, and my answer is simple way 5 minus 3 2, 1 minus 4 minus 3 and 6 minus 1 5. So equation of line AB is clearly known, that you formula is R is equal to A passing through plus lambda AB directions, where lambda belongs to R, and simply you put it down A value and directions AB. So R is same as A, I have just write down 3 4 1 lambda and AB directions 2 minus 3 5. But this equation I will show that in xi plus yj plus zk. This side also same, 3i plus 4j plus 1k, and here same lambda 2i minus 3j plus 5k. Now you add the 3i and 2 lambda I, so you will cover xi yj zk is equal to 3 plus 2 lambda I. This first with that first. Similarly students, 4 minus 3 lambda j, 4 minus 3 lambda j, and last 1 plus 5 lambda k. and that's the one of the comparisons wise your x, y, z value ready. But point on that xy plane necessary, the position is xi, yj and 0k, so that I take 0 and define value of our lambda and easily define your answer. So just I write down only one little statement. Line AB cross the which plane? XY plane at the point, very easy, is x, y, 0. That's why position vector of P is that xi plus yj plus 0k, and that I simple put it. Your just comparison here, x is equal to what? 3 plus 2 lambda, y is equal to students 4 minus 3 lambda, and last z is equal to 1 plus 5 lambda. But I will taking that this coefficient of z is 0 here. Therefore further steps, if z is equal to 0, so 1 plus 5 lambda is equal to 0. Why 0 taking? According to crosses the xy plane. So students, my lambda value minus 1 by 5, and that value submit in xy place. So your x is ready, 3 plus 2 lambda, my lambda value is minus 1 by 5. So 5 3 is a 15, minus 2 by 5, it will 13 by 5, x covered. And same as students, I will go to y, 4 minus 3 lambda, lambda is a minus 1 by 5. So your answer is 5 4 is a 20 plus 3 by 5. Your answer is 23 by 5. Now z already 0. So required, what your target? Read the question. Find the coordinate of point on the xy plane. So required point on the xy plane, which is P x y 0. I just submit xy 0 value. X is a 13 by 5. Same as, again I write down, don't worry students, it is 13 by 5. Second, y is a 23 by 5, and z covered to 0. Now students, example 30 over that. Now after that I going exercise 11 related same questions for that combined example 30 related question number 10 and question number 11. Just only plain change. So exercise 11, question number 10. Find the coordinates of the points which are intersection. Now yz plane. Yes, here only this change. YZ plane, and given that point 516.8, 516, and second 341, and given the plane YZ plane intersection. One more time, check 516 and 341. So very easy students, only A and B is change here. So this plane is change, point change, and this side the directions also change. So drawing is same students, AB line passing through on it, but which plane? YZ plane. So here x coordinate is 0. So what the position of P? 0 YZ, and that way I covered to first of all line AB. So direction of AB line is AB directions, B position minus A positions. What the B positions? 3 4 1, A is a 5 1 6, and you will get simple 3 minus 5 minus 2, 4 minus 1 3, and 1 minus 6 minus 5, indirectly minus 2i plus 3j minus 5k. Direction of AB. Now AB directions and passing through on it, you know the first point is A. So equation of line AB having direction, this direction students, minus 2i plus 3j minus 5k, and passing through, what the passing through taking? First a, yes, 5i plus 1j plus 6k. So very easy, your AB equations is a r bar is equal to a plus lambda of AB directions. A I have here xi plus yj plus zk, and here a students only the passing through on it, 5 1 6. I will write down 5i plus 1j plus 6k, and AB directions here already known that minus 2i 3j minus 5k. Now I will cover same process, only point change. Just here I explain to xi, yj, I and I related you combine taking, so 5 minus 2 lambda I, next 1 plus 3 lambda j, 1 plus 3 lambda j, and last 6 minus 5 lambda k. And here students, you will compare just both sides, x, y and z coefficients. Now similarly for the line AB crosses the which plane? Yes, yz plane. So point is what? 0 yz, and position vector for the P is 0i plus yj plus zk are same, and just you compare x, y, z students, and you will cover to answer. Only compare the value with the parallel to that, this x, that y, and this z. So what's your x? 5 minus 2 lambda. Second, similarly y is 1 plus 3 lambda, and last 6 minus 5 lambda. But you know that according to suggestions on the yz plane, x coefficient is 0. So I will start from here, from that conditions, x is equal to 0 taking. So x is equal to 0. So 5 minus 2 lambda 0. 5 is equal to 2 lambda. Lambda is equal to students 5 by 2. And putting down on y and z, therefore y 1 plus 3 lambda. Now what is the 3? Lambda I value is a 5 by 2. So my answer is a 2. 5 3 is a 15. It covered to 17 by 2. And similarly students, z, you also write down 6 minus 5 lambda. What is the lambda? 5 by 2. So 6 2 is a 12. 5 5 is a 25. It covered to answer minus 13 by 2. And all values we just putting one by one. So required point on the which plane? Yes, on the yz plane. Point P is you know that yz plane 0 yz, it is 0 17 by 2 and minus 13 by 2. That's your little answer is correct. Now students, I go to ahead next questions. Question number 11 is the same question, 5 1 2 also same given and 3 4 1 given, but now zx plane, here only change zx plane. So it is indirectly whole numerical are same, only this a change, here point P changing, and here I will write down to zx plane. So can you guess the? Yes, correct, y coordinate is 0, so here x 0 z in the zx plane. This question are same solutions, up to that same, this also same, and all up to that x y z is same calculations. Only this I change, here I will write down zx plane, coordinate change and positions change, and that's why students this answer is also changed. So left hand side solution you same as write down according to previous sum. So these all are same calculations, only zx plane, so x0z, here I mention crosses the zx plane, and P position is what? x0z, it is xi 0j plus zk. Here y coefficient 0. So you cover to x, y, z. Here your x compare again 5 minus 2 lambda, 1 plus 3 lambda, and last 6 minus 5 lambda. Indirectly same calculations, only lambda change because the line crosses the which plane? Zx plane. So here I will take y is calculation is 0. So very easy. Yes, we take y is equal to 0. That's why 1 plus 3 lambda is equal to 0. It means 3 lambda is equal to minus 1. Lambda is minus 1 by 3. And very easy, putting in x and z. So what's your x? 5 minus 2 lambda. 5 minus 2, but lambda is a minus 1 by 3. My answer is 5 3 is a 15 plus 2. So answer is a 17 by 3. And very easy, you cover to z also. 6 minus 5 lambda. 6 minus 5, but lambda is minus 1/3. So 6 3 is a 18 plus 5. It is 23. So the required point is easily derived. Last we write down required point on the which plane? Yes, on the zx plane, which is P. The zx plane point x, 0, z. What is x? 17 by 3, 0. And student z is also same, 23 by 3. And that's the easily you get the answers for the question 17 by 3, 0 and 23 by 3. Now students, after ending 10 and 11 question, I will start from the first questions to exercise 11. Now students, continue ahead. In the first questions, first I go to legally questions. And that also very easy. But now students, in exercise 11, almost all points are revised in one by one over these questions. So in exercise 11, question number 1. So now students, I going ahead, exercise 11, question number first. Show that the line joining origin and the points 2 1 1 is perpendicular to line joining to determine the points 3 5 minus 1 and 4 3 minus 1. It's very easy. First of all, I just draw general questions. Here origin and the point A 2 1 1, and another students line owner given to BC, just like any 2 points. B is a 3 5 minus 1 and C here 4 3 minus 1. I want to prove anyhow these lines are make perpendicular, means direction of OA and BC dot product is 0. Very easy. First of all, I derive direction of OA directions. So A positions minus O positions. What's the A? 2 1 1 0 0 0 2 1 1. So I will write down only 2i plus 1j plus 1k. Same as I go to now directions, another BC. So BC either CB is correct, students. BC direction means C positions minus B positions. What does C? 4 3 minus 1 and B is 3 5 minus 1. Now check, it is your 1, next minus 2 and 0, indirectly 1i minus 2j plus 0k. Now I will prove to anyhow it is your dot product 0. I mean I will prove it is a perpendicular to each other. So it's very easy. Only I will show here to direction of both dot. So now O to A directions dot B to C directions. Both direction dot product I will start first 2i 1j 1k and BC also same 1i minus 2j plus 0k. And here students you will take dot product 0. 2 1s are 2 minus 2 plus 0. Yes, confirm. We show that here this answers for O to A line perpendicular to BCC line. And here students, your question number first is happily and easily students here done. Now students, in the question number second is also very easy. If L1 M1 N1 and L2 M2 N2 are the direction cosines given for the two different mutually perpendicular lines, show that direction cosines of the line perpendicular to both L1 and L2. Just I prove that first this, second this, and a third this. Very easy. First of all, given line L and M have two direction cosines. I will just show by using in the diagram. Consider here your first line L have direction cosines given, the second M given, and both perpendicular to that. These lines I will prove for that direction is N. This direction is a L1, L2, L3. Either you will write down this is your L1, M1, N1. I just write properly L1, M1 and N1. And second direction cosine is a L2, M2 and N2, and which are perpendicular to both. So very easy. I will go to perpendicular already. It means cross product for the first directions and second direction. So direction cosine of required line N, which is very easy. This direction and this direction cosines L1, M1, N1 cross. I will take second L2, M2 and L2. Students, here using the right hand thumb rule. This is line L, that is line M. So third line is perpendicular to on it. It is your cross product, and that cross product I will show by I, J, K using determinants L1, M1, N1 and L2, M2, N2. Apply on it I minus of J and plus of K, and simple take calculations. M1 N2 minus M2 N1. And next students, here L1 N2 minus L2 N1, and at the last is L1 M2 minus L2 M1. Just to rearrange, M1 N2 minus M2 N1 I, here plus this I first write to positive values. So minus minus plus L2 N1 minus L1 N2 J, and last of the L1 M2 minus L2 M1 K. These are three our direction cosines to required directions. So last I write down required direction cosines are the simple way M1 N2 minus M2 N1 comma, means that next N1 L2 minus L1 N2, it means second N2 L1, and last comma L1 M2 minus L2 M1 is the last one, L1 M2 minus L2 M1. And that the students, your this question second is easily and happily students here ending. Now students, here question number second ending. I will stop this video, and further explanations for exercise 11 I will explain in the next part. Bye bye.